Welcome back. In this video, we are going to cover the different types of views and the DDL statements to create the same. Views are quite similar to tables, and like tables, it consists of rows and columns. But the difference is, the contents of a view are defined based on a SQL query. In regular views, the data is not stored anywhere, but in case of materialized view, the data is stored in the disk. In parameterized views, the view is defined based on the parameters, which is not resolved immediately at the time of view creation. Let us look at these in detail in this video. Let us create a view based on this salary table in the SQL_examples database. This table has 3 columns: salary, month, and name, and this table has 3 rows of data in it. Let us begin by creating a view. To create a view, we will have to use the create view statement, followed by the database name and the name of the view, and this is followed by the as keyword, and the contents of the view will be based on this query. When we look at the contents, we can see that the values in the salary column are doubled when compared to the original table. This view doesn't store any data in the disk, and when we query the view, the data is read directly from the original table. Let us now look at parameterized views. A parameterized view is similar to the regular views, but the difference is a parameterized view is defined with parameters. To create a parameterized view, we will have to use the create view keyword, followed by the name of the parameterized view that will be created, and then we have the as keyword, and then we have the select statement based on which the data will be present in the view. But note that we have a where clause, and in the where clause, we have a parameter in this expression. In this case, the rows will be filtered based on the values in the column 1, which is parameterized. To read the data from the parameterized view, we can use this select statement. And when we specify the view name, we will have to pass the values to the parameter that was declared at the time of view creation. So when we read the data, we will have the rows where the column 1 value is equal to A. Let us now move on to the materialized view. Unlike the regular view and the parameterized view, materialized view will store the data separately. Instead of create view keyword, we will have to use create materialized view keyword. This is the database name and the name of the materialized view, and this materialized view is going to use merge tree table engine. This order by clause is mandatory for any merge tree table engine, and then we have the as keyword, and finally we have the select statement based on which the data in the view will be populated. So like the regular view example, we are going to double the salary. So let us go ahead and create this view. Once it is created, if we look at the data in the materialized view, we can see that the data already present in the salary table is not readily available in the materialized view. Let me insert a row of data into the salary table. After that, if we read the data from the materialized view, we can see the new data that was inserted. Let me now update the newly inserted row in the salary table. Here, I am going to update the salary value. And when we read the data from the materialized view, after updating the data in the salary table, we can see that the changes are not reflected here. So in any materialized view, only the inserts in the source table is captured, but other manipulations like updates and deletes are ignored. So this is all about the views that are available in ClickHouse. Thank you and see you again. Hello and welcome back. In this video, we will cover the joins and unions that are supported in ClickHouse. Joins are used to combine records from 2 or more tables based on a common and related column. ClickHouse supports inner join, left join, right join, full join, and cross join. To perform a join between two tables, we need at least one column which is common between these two tables, and this column is also known as related column. This is the syntax for performing joins on two ClickHouse tables. These two tables are called left table and right table, and left table is the one which appears to the left of the join clause, and the right table is the one which appears to the right of the join clause. So we start by selecting the list of columns, which could be either based on expressions or simply the columns itself, and this is followed by the from keyword and the name of the left table, which is then followed by the join type and then the name of the right table, and then we have the on clause, and this on clause can have one or more expressions. These expressions would contain the join keys. Let us move on to a practical example. To illustrate the joins, we will create two tables called employee and salary. So the employee table has two columns called name and city, and the salary table has three columns called salary, month, and name. So you can see that the name column is common between these two tables. I have now created both the tables. I will first insert 3 rows of data into the employee table. Next, I will insert 3 rows of data into the salary table as well. So all the 3 rows are available in both the tables. Let us first look at the inner join. Inner join returns the records with matching values in both the tables. In this example, we are selecting the columns from the employee table, which is the left table, and we are performing inner join with the right table, which is the salary table, and the join is performed based on the name column, which is present in both the tables. This is the result set of the inner join. We have only 2 rows with name A and B because only these two names are common in both the tables. Let us now look at the left join. Left join will return all the records from the left table and the matching records from the right table. In this example, I have only changed the join type and rest of the statement remains the same. We can see that all the 3 rows from the employee table is present, but since there is no data for the name C in the right table, which is the salary table, the salary and the month values are null in the result set. Let us now perform a right join. Right join will return all the records from the right table and the matching records from the left table. I have changed the join type here. As expected, we have all the records from the right table, and since name D is not available in the employees table, we have the city and month values as null. Let us now look at the full join. In full join, records from both the tables are returned, and in case of non-matching records, nulls are filled in appropriate columns. As usual, I have changed the join type here, and rest of the statement remains untouched. We can see that all the 3 rows from the employees table and the salary table are here. Since name C from the employee table has no matching records from the salary table, the salary and month values are null. Similarly, for the name D in the salary table, we don't have matching records in the employee table, and hence we have null in the city and month column. Let us now look into unions in ClickHouse. Unions are used to combine the result set from multiple select statements. To perform a union, we have to use the union all keyword. Note that the number of columns in each select statement must be the same, and the columns of same ordinal position must be of the same data type in each and every select statement. In this example, we are going to perform an union, and we are going to select the data from 2 different tables. We have selected the name column from the employee and salary table. This is the result set combining the values present in the name column of both the employee and salary table. In order to retain the distinct values, we have to modify the existing query and we'll have to make use of the distinct clause. So that's all about unions in ClickHouse. Thanks for watching and see you again.